All right, so we're talking about plate tectonics today, and we're going to talk about why it concerns us. And obviously, being that we live here in California, it should concern us, right? Because there is earthquakes all the time. Now, a lot of scientists chalk it up to this idea of living on an eggshell. I don't necessarily like that analogy because an eggshell, of course, it doesn't move, and not that, these are swirling, these plates, different plates are swirling around, but they kind of are, okay? We're talking about millennia. It takes a very long time for them to actually move and create these landforms. But that's how we get our landforms created, is through this plate movement. All right, and there's a variety of different boundaries because some of them are pushing, some of them are pulling, some of them are going across each other, some of them are separating. So we're going to get more detail on that, okay? If we look at the map here, we can see right here, this is the Pacific plate. This is the North American plate. We got the Eurasian plate over here. So lots of different plates floating around. Of course, these should be the most concerning to you guys and to us because this is where we live. When you feel that earthquake, when you feel those earthquakes, it can be jolting sometimes. It can definitely freak us out. I think I was I was slightly younger than you guys. I remember I was getting ready for school. I went to middle school at Richardson, and I just remember there's a big earthquake in the morning, and I tried running to get in a doorway, a bathroom, under a table, and it was like my legs were rubber, right? Because it was such a big earthquake. Another big earthquake I was in. My family and I, we were about to take a road trip, or we were flying. I think it was a road trip out to New Mexico, and we went to go gas up the car just before we were about to leave, and we're using that gas station on the corner of E Street and 30th. I think it's a Shell. Yeah, I think it's a Shell. But anyways, that big awning, that covering over the cars where it gives you shade, started racking back and forth, and we're under it. Okay, the windows of the glass were pulsating. It was a pretty intense earthquake. So if you're ever in an earthquake, of course, stay away from glass and things like that. All right. So how many earthquakes in the last 7 days? Now this is just an average. I just grabbed this back in 2008. Grab this picture real quick from the earthquake site, and this is just average. Okay, nothing very major. A bunch of little small microquakes. If you look right here, you can see by their size, this is a 1, a 2, a 3. There's no 7s. That went on during this time, but a lot of small little microquakes that you might feel or you might not feel. I know myself, I don't pick up on them very readily. Usually, I can tell that there's an earthquake by the little pull chain on the ceiling fan, or last time there was a good sized earthquake that I should have felt. I was out in my backyard. I was doing some yard work. I was doing something outside, and I was walking back and forth. I didn't feel it, but I noticed the water sloshing out of the pool. So it was a good sized earthquake if it's going to move that water in the pool enough to kind of slosh out. So definitely a good sized earthquake. Okay, so you don't need to write this down yet, and do keep in mind that anything that comes out of my mouth is fair game for an assessment. So when we see plates collide, we're going to see different landforms happening. Now, we're going to go over each one of these individually, so you don't necessarily need to write these down yet. But the main boundaries we're talking about are convergent, divergent, transform, and collision or collisional. All right. When we're looking over here, we can kind of see those arrows. This is sliding across. Up here, they're crashing against each other, separating right here. The Mid-Atlantic Ridge right here, this is all a separation here over here in Africa, where the Horn of Africa, we'll talk about this a little bit more in depth, also separating as well. All right, so the first one we're going to go ahead and talk about is a convergent boundary, or convergent boundaries. And this is where plates, they're crashing together, right? So it's not just two continental plates, however. When we're talking about a convergent boundary, you're going to have an oceanic plate and you're going to have a continental plate. And because these are two different types of plates, something different is going to happen if it was two continental plates instead. So what's happening is this weight of this water, it's pushing down on that oceanic plate because it's, water's heavy, pushing down on that oceanic plate. And what we see in this case is that oceanic plate is going to dive underneath that continental plate. And we're going to see certain types of landforms. So it's going to dive down, it's going to melt, and it's going to come back up as some type of volcanic activity. Now, it's this type of boundary where we see this thing called subduction occur. So it's subducting, that oceanic plate is subducting underneath that continental plate, melting and coming back up as, a volcano, an active volcano. Now, subduction doesn't only occur on on convergent boundaries, but it also will happen in transform boundaries as well, and we'll talk about that here in a second. Any questions on that before I move on? All right, let's go ahead and go to our next one. This is referred to as a collisional boundary. When two land masses meet each other, so these are two continental plates meeting each other, and what's going on is they're coming together and they're going up. They're creating huge mountain ranges like the Himalayan mountain range and also the Hindu Kush. So if we look over here on this map of India, this is the subcontinent of India, and it's crashing into Asia. Being two land masses, neither of them wants to give up. Neither of them wants to subduct, so they go up. What's the path of least resistance? Go up. So these ones go up. And it creates the Himalayan mountain range and also the Hindu Kush over here. So we do see the two largest mountains in the world in this area of the Himalayas and also the Hindu Kush. Okay. We do have evidence that other areas of the world also had collisional boundaries. So if we look at our Appalachian mountain range on the East Coast, at one time that used to be a collisional boundary, but anymore it's not. It's fused together. Okay, and because so much time has passed, when it was a collisional boundary and now it's fused between weathering and erosion, those mountains have shrunk. Okay, they've melted away because of the freeze-thaw cycle, because of weathering, because of erosion. Okay. We know that there are two separate plates because we see two different types of soil structures and also different types of rocks. Okay, so we know that at one point they were crashing against each other. They fused because on either side of that mountain range, we do see some differences in soil structure and also rock. Okay. Next type of boundary is a divergent boundary. So a good example of this is in Africa. So if we look over here, this is referred to as the Horn of Africa, and it's breaking away. It's separating from the rest of Africa. And so we're going to see a lot of earthquakes. Okay, this is just average earthquakes in a year's period, but we definitely see some structures here, like different lakes, because it's splitting, it's opening up. So that water, it's going to want to go down to the lowest point. And so we do see Africa's largest lakes in this area due to this divergent boundary. Now, not only in Africa do we see this, but we also see it in the Mid-Atlantic Ridge. So let's see if I can move this box a little bit. Nope. Just go like this. So if we look right here, this Mid-Atlantic Ridge that we see does create the world's longest mountain range. Okay, and it's underwater. Okay, and most people would say, oh, it's the Andes, it's the Rockies, it's the Himalayas. The Andes and the Rockies, yeah, they're extremely long mountain ranges. But as you can see here, this Mid-Atlantic Ridge is creating the largest mountain range, and it's underwater. Now, the Atlantic Ocean, because of this, is actually getting larger as time progresses. So let's go back real quick. So if you see right here, the Atlantic, it's separating, all right, and it's pushing Africa farther, and it's pushing South America and North America farther away from each other. So it's a divergent boundary. Now we also have to keep in mind the planet doesn't grow, right? So because it's not growing, if the planet isn't growing, these plates need to be consumed somewhere else, and they're being consumed in wherever they're pushing out. Okay, so the Pacific Ocean, that's actually subducting and it's getting smaller. All right. Ooh, we're going to have to move some of these pictures. that I have to do this because I'm recording and I'm not presenting the slide using the present button up here. All right, so transform boundaries, places where plates slide past each other. And I really don't like using that term slide past each other because they're not sliding, right? I mean, this is rocks going against each other. So what I would like for you guys to do, make two fists, interlock your knuckles, press really, really hard, and try to separate them. Don't punch yourself in the face, okay? Try to separate them, and because your knuckles are interlocked, it doesn't want to go apart, right? So it doesn't want to slide past each other, and that's what we're thinking. You know, that's what we got to think about. You know, it's rock connected to each other, and it doesn't want to just slide. So when it does slide, it jerks or it jolts, and that's what the earthquakes are. If you put your hands together like this, you know, even make it even more tough. The tougher it is, the bigger the earthquake, and that's what we're going to see. That's what we see with large versus small earthquakes. Now, the pictures that I was showing you that were up here before, let me put those back. So this one right here, this is actually along I-5 on the Grapevine. So if any of you have gone over by Magic Mountain and kept going north, you go up over the Grapevine, and this is a picture. This is the North American plate, and this is the Pacific plate. Okay, we can tell which plate is which by the type of soil structure and by the types of rocks. So this is very obvious to us where these different plates lie. Okay, this other picture I showed, this is behind Cal State. Some of you guys might be somewhat familiar with this. And if you look back here, there's a line of trees. This line of trees is there, this green line of trees is there because that's where the San Andreas Fault is. The San Andreas Fault, it's a bunch of fractured rock right there, kind of rubbly underground, and those trees are able to get their roots all the way down and to get water. If you look everywhere else, there's no trees. The reason for that is because they're able to get that water through the San Andreas Fault, through that fractured rock, and pick it up. Okay, so those of you who live close to the foothills, it's one of the reasons our mountains exist the way they do, is because we do have that San Andreas Fault running along the base of the San Bernardino Mountains. Okay. Questions? I do. Can you go back, Isaiah? I do have these notes in Google Classroom. I'm also going to post this video too, okay? All right, so what you guys get to do now, I want some work from you. It says right here, it says summarize your notes at the end of your notes and create some questions using the key ideas in your notes. Now, personally, I like for you guys to create your summaries just prior to an assessment. That way it's a refresher, right? You look at your notes. Okay, that's what we talked about. That's what we talked about. Okay, let's go ahead and summarize that. It's a good study tool to do just before you take an assessment, or you could do it now too, and then just go back and review. Now, as far as production on a separate piece of paper, what I want you to do is tell me, and this is all on one piece of paper, I want you to tell me what boundary interests you the most and why, and then also draw those 4 boundaries. You can use the images I showed in the slide presentation, or you can just Google it and get your own images and do it a little bit differently. Ideally, I would like to see this in color. So if it's an oceanic plate, definitely color in that water of the oceanic plate, brown for continents. You'll want to do red or yellow as it goes down and melts. If you're doing a divergent boundary, you're going to want to show it spreading apart and magma coming up, lava creating a larger plate. You're going to want to put some arrows, like where are things going? Is it, if it's converging, you're going to dive it down. If it's collisional, it's coming together and going up. If it's divergent, it's going out. If it's transform, it's going across or sliding, right? So that's what I want from you guys. Any questions on that?